Hello and welcome to this second video from SMS Projects. I'm Stu Stones, and in this video we actually have some tech. Here in my loft I have three computers, one which I use day to day for office apps, video editing, writing, etc. One is a TV server which performs PVR and media center functions, and the third runs backups of my data to LTO tapes. Considering I run a cloud infrastructure as part of my day job, I think it's high time I consolidate my tech, optimise resources and reduce my electric bill. So in this video I'm going to talk about the hardware, build it on the bench and download and install unRAID Server 6. Part of what I want to do on this channel is not to always default to the latest hardware. After all, there are plenty of channels on here which review what the uber enthusiast can buy. What I want to do is pick the best of the used market at the time, throw in some brand new hardware where necessary, and build something which any enthusiast can build and still get good results. So with a budget of just £200, I tasked myself with sourcing the core for my new rig, and ended up with the following three items. I managed to pick up this Intel Xeon E3-1240 for a really good price. It supports 4 cores and 8 threads running at 3.4 GHz and a single thread turbo boost of 3.8 GHz. I chose this CPU because it offers comparable performance to the i7 I'm running in my main PC, but as a Xeon it offers two major advantages. A much lower TDP, or energy use, of just 69 watts compared to the 95 watts of my i7. And secondly, access to more PCIe lanes, meaning more hardware on a single board can be addressed at top speed. Another advantage is support for ECC memory, but that's an upgrade for another day. The motherboard is where I needed to dedicate most research, because I wanted a consumer grade board within budget that not only supports the Xeon E3-1240, but more importantly openly supports Intel VTd, which allows physical hardware to be ignored by the hypervisor and passed straight through to the virtual machines as if it was physically attached. Having digested the content on this page and seeing what was available, I found this used ASRock Z77 Extreme 6 again for a great price on eBay. It supports 100% made Japanese capacitors, an 8+4 phase power supply, 4 PCIe slots, 2 PCI slots, Realtek 7.1 audio, Broadcom Gigabit Ethernet, 4 SATA 3 6GB ports, 4 SATA 2 3GB ports, a plethora of USB 2 and 3 ports, and perhaps most randomly, a floppy port for those who wish to relive those days. Overall, this is a great board, and although I'm usually a member of the ASUS camp, I'm more than happy this time to embrace this great ASUS offshoot. Memory was far easier to find. With the remainder of my budget, I found this 16GB Kingston Value 4x4GB kit. The motherboard can support up to 32GB of RAM, so room for a future upgrade. My hypervisor and control software of choice is unRAID Server 6. I chose unRAID after watching a YouTube famous Canadian who used unRAID to virtualize multiple gaming rigs. I saw the potential for productivity virtualization as well as gaming. unRAID needs its own USB flash drive for boot, so here I have a 4GB Kingston Data Traveler USB drive. Any flash drive over 512 MB will work, providing it has a unique serial number which can be registered against your unRAID license. unRAID requires its own dedicated GPU for console operations. Usually onboard graphics would suffice, but as my Xeon processor doesn't have any, instead I have this Sapphire Radeon HD 5450 1GB, which I'll use in the topmost PCIe X16 slot just for accessing the unRAID console. I had originally intended to use this HP branded ASUS 8400 GS PCIe X1 adapter in the very topmost slot as a sacrificial card just for the console. However, this motherboard prefers any PCIe X16 slot over the X1 slot for graphics, even with this mod I found online to trick a motherboard into accepting graphics cards in that slot. So that card went back into my parts bin. As I'm virtualizing my main PC onto unRAID, I need another GPU which can be passed straight through to the VM, with its output on my monitor rather than the VM's remote connection. I got this Radeon R7 250X on eBay for this. I chose this card because it's been found by the community to work inside unRAID in a VM, and shouldn't suffer from any problems with resetting if I reboot the VM. For power, I have a Cooler Master RS460 standard ATX power supply, and for storage, 4 Western Digital Red 1TB NAS drives mounted in a RackMax RM124 hot swap SAS and SATA 4-bay enclosure.
Download and install unRAID Server 6 to our USB flash drive. Dead easy to do, it should only take just a couple of minutes. In your favourite web browser, go to the homepage of lime-technology.com. They've got some great resources online, their own YouTube videos and lots of information. If you want to learn more, check it out. In this case, we're just going to download unRAID Server 6. We're going to click on Downloads, click on Download unRAID Server 6. And while that's downloading, we can prep our USB flash drive. So we can insert that into the system now. And you'll see this flash drive has come up as Kingston. So what we need to do is reformat the flash drive for unRAID. Right click the USB flash drive, I'm doing this on Windows 10, and click on Format. You want to change the file system to FAT32 and change the volume label to unRAID, all in caps. Quick format's OK, and yes, we really want to format the drive. Format complete, that took just a few seconds. We can now close this window. By the time the format's done, we can see unRAID has finished downloading, so I'm going to open the zip file now. Right click all the files and copy, and click on my USB flash drive and paste. Now that's done, there's one final thing to do. On a Mac it's slightly different, but here on Windows 10 I'm going to right click on makebootable.bat and click on Run as Administrator. What that will do is run a command on the USB drive that makes it bootable. Here it's selected drive F, which is unRAID, which is correct. So we'll press a key to continue, and press a key again when it says completed. And that's it. We can now eject our USB flash drive. Job done. We can now plug this flash drive into our hardware and boot into unRAID. So here we are, all the parts are on the bench, and along with a motherboard tray from an old case I can use to test build the rig. Let's put everything together. First thing I'm going to do is 9 screws into the motherboard tray. Those of you who watched my first video on this Amazon toolkit, a little bit of an update. The toolkit appears to have lost all its magnetism after just using it for a couple of weeks. So the screws no longer properly hold to the bit. The next thing I'm going to do is put the CPU and apply some thermal paste. Here is the CPU, as shown before, the Xeon E3-1240. All I'm going to do is open up this socket on this motherboard, align the CPU. You'll see there are 2 locating pegs on the socket. They're going to line up with the 2 locating pegs on the side of the CPU. They go on there, and that just clicks into place. Using a pre-injection swab or anything containing some isopropyl alcohol, I'm just going to give the CPU and the bottom of the CPU cooler a little bit of a clean. That just makes sure that there's no dust or contaminants or old thermal paste. And that just takes a moment. Here's the thermal paste. This is Cooler Master IC Essentials E1 paste. You only need a small amount on the CPU, in the middle, about the size of a pea. I'm going to not scrape and just put the CPU cooler directly on top. CPU coolers, at least the Intel stock ones, the arrows need to be pointing away from the CPU cooler itself. That makes it easier to install. And when you want to extract the CPU cooler, you turn the handle so the arrow points towards the CPU cooler, and that makes it easier to extract. However, to insert it, the arrow wants to be pointing away from the CPU cooler. You want to connect the CPU cooler to the CPU fan 1 header on the motherboard. What I like to do is twist the cables together just to make it a little bit neater. Next I'm going to install the memory into the 4 slots. Because we're using dual channel memory, it doesn't matter which slot you start from or which slot you put the memory into. So we're just going to start and put the memory into each slot. Next thing we're going to do is install the graphics cards. So first of all we have the HD 5450 Radeon. This one's going to be for the unRAID console itself, and this one's going to go in the top PCIe X16 slot. Just like that. And the second graphics card is the R7 250X, and that's going to go into the third PCI slot. Here is the power supply. It's the Cooler Master RS460. It's not a modular power supply, therefore all the cables are included. So first of all I'm going to do the P1 and the P1A connectors. Next to this motherboard has a standard Molex connector and is designed for use when you've got more than one graphics card installed. Obviously this motherboard does now have more than one graphics card, so I'm going to pop a Molex connector into there to provide some extra power. The next thing I'm going to do is supply Molex power to my 4 hard drives. And before I forget, extra CPU power. Going to attach a HDMI cable to the first graphics card. Connect up the power. Insert a network cable onto the onboard network card there, and that's so unRAID can get an IP address. And the very last thing I'm going to do is install the 4 SATA cables between the onboard SATA and my 4 hard drives. I'm going to add one final thing to my motherboard here. I have this USB external bracket. I'm going to undo the screws on these brackets to remove one of the USB connectors. My USB drive from earlier, my Kingston drive, can sit inside this, and this can now go onto the motherboard. We're going to fire it up and give it a go. Turns on, the postcodes come up on the little screen. All looks good so far. Let's head over to the monitor and check out what the BIOS is spitting out. Now the hardware build is complete and the USB drive ready, there are a few BIOS settings you need to check. On this board the settings are shown here, but your board may differ. Ignore the clock, I know the date's wrong, it's not January the 6th. First thing I'm going to do is go into Advanced and CPU configuration and make sure that hyperthreading, no execute protection and Intel virtualization technology are all enabled. The next things I'm going to do under Northbridge is make sure the primary graphics adapter is set to PCI Express, and Intel VTd, which allows hardware to be passed through, is also enabled. Under storage configuration, I want to make sure that all drives have been detected and that the SATA controller is enabled and in AHCI mode. The final thing I want to do is make sure that the system can only boot to the USB drive, so I'm going to go to the boot menu and disable all options other than USB Kingston data travel. Now that's done, I'm going to save the changes and exit, and the system should boot into unRAID. Now unRAID server is booted up, you can see by DHCP it's got an IP address of 192.168.73.221. We might need this IP address in the next section, so make a note of it and head over to your PC and your favourite web browser. Now your unRAID server is fully booted, go back to your PC, open a browser and go to http://tower. If this doesn't work, you can try http:// and the IP address of your unRAID server as shown on the console. I'm doing this on Windows 10 with unRAID 6.2. Macs, other versions of Windows, and other versions of unRAID may differ slightly. You will see it lets you straight in without asking for a password. We'll fix that later. The first page you will see is the registration page. Here you can purchase a license key, request a trial, or paste in a key you already have which matches the GUID of your flash drive. It's important that your server time is correct. My BIOS reported the system time incorrectly during my build, so before I apply my license, I'm going to update the time. Click Server Time, and although the time has been set now, my time zone is still wrong. So I'm going to set my time zone to the UK, and then click the banner to be taken back to the registration page. Requesting a trial key only takes 2 minutes and is delivered by email. I already have one, so I'm going to paste it in now. The next thing you need to check is click on the info link and ensure that HVM and IOMMU are both enabled. If they're not, you may need to go back and check your BIOS settings. Next, you should set a root password. This ensures your system is secure. To do this, click Users on the menu and click Root. If you want to change the description or set an avatar pic at this point, you can. Type in your new password and click Change. Once done, you'll have to log back into unRAID with your new root password. Next, we'll change the name of our server from Tower to something else. Click Settings and then Identification. Here you can change the name of your server, its description, and change the model information if you choose. Click Apply. Once your new name has taken effect, log back into unRAID using the new name instead of Tower in your browser. Go back to Settings and Network Settings. First, make sure Enable Bridging is set to Yes, as it should now be done by default. For advanced users, it's also good practice to have static IPs for servers on your network. Change IP address assignment from automatic to static, and change your IP settings according to your network setup. Click Apply when done. Depending on how much you've changed, this may take a few minutes to take effect, and you may need to refresh your browser a few times. When complete, click Done to return to settings. I would recommend enabling notifications so you can be alerted to what's happening with your server. To do this, click Notifications and change System Notifications from Disabled to Enabled. By default, unRAID only allows browser notifications. These pop up in your browser when you're logged in, but only when you're logged in. If an event happens while you're away, it's useful to know. So I'm going to enable email notifications for all actions and click Apply. Next, we need to tell unRAID how to email me, so I'm going to fill in my email settings below. If your email provider isn't shown on the pre-populated list, you can manually enter SMTP settings. Click Test and make sure you get a test email from your server. Click Done to take you back to settings. Next, enable file sharing for clients on your network. From Settings, click AFP if you have Apple Macs on your network, NFS for Linux, SMB for Windows PCs is enabled by default. Since I have Linux clients on my network too, I'm going to enable NFS by clicking on NFS and changing Enable NFS from No to Yes. Click Apply and click Done when done. Now it's time to set up our drive pool. Click Main on the menu. Here we can assign drives to either the array or cache. Today I'm just going to set up an array with no cache. I'm going to change the number of slots down to 4, which matches the number of drives I have. This also makes the screen less cluttered. Starting with the parity drive, add drives to your pool. It's always best to assign the largest drive to parity if you have mixed capacity drives. With all your drives in the array, scroll down and click Start. Once your array starts, your disks may show up as unmountable. To fix this, click the tick box under Format and click the Format button. This will reformat your drives for unRAID. If you had any data on these drives before, it will be wiped, so make sure you want to do it first. Keep refreshing your browser and you'll see the status change one disk at a time, showing the capacity. You will see in the bottom left it says Parity Sync. This is unRAID setting up the redundancy in the background. Although you can use the disk array now, bear in mind the data won't be fully protected until this completes. Now it's time to add some shares. Click Shares and then under User Shares, Add Share. I'm creating 3 shares, one to store ISO images, one for virtual machines and one for my data. Call the first share ISOs, leaving all other settings as is. If you have a drive cache option, select No for this share and then click Add Share. Next, virtual machines. Again, all settings as is, but click Yes to drive cache if you have that option. Add the share. Finally, user data. All other settings as is. This time, select Yes to the cache if you have that option, as it does make accessing frequently used data much quicker. Click Add Share, and now click Done. Click back on your ISO share, and select Yes to export the share to the network. Apply and Done. Click on the virtual machine share, but this time don't export it to your network. Apply and Done. Click on your user data share and do export it to the network. Apply and Done. Finally, we need to enable unRAID virtualization support. Go to Settings in VM Manager and change Enable VMs from No to Yes. Next, set the default VM storage path to your virtual machine share created previously. Click off the box to save the change. Do the same with the default ISO storage path. Select the ISO share just created and click off the box to save the change. Next, download the Windows virt.io drivers. Previously you had to download them separately from the Fedora project website. Now you can download them direct into unRAID. Simply click the latest version of the ISO to download and click the download link. This will download direct now to your ISO share. Next, change your default network bridge to BR0, which is the one enabled earlier. Click Apply and Done, and you'll see that a new tab of VMs has appeared in the menu. Your unRAID server is now complete and ready for saving your files and running virtual machines.
So with my bench build now complete and unRAID server installed, that's it for this video. Next time I'll be showing you how to install Windows 10 as a virtual machine and pass through the graphics cards and USB devices. See you then.